Welcome to the Colorado Professionals and Onsite Wastewater presentation on how to create a record drawing. This presentation will identify what a record drawing is, why it is necessary, as well as the various ways a record drawing may be created. Prior to the updates to Regulation 43 in 2018, the term typically associated with a drawing created after an onsite wastewater treatment system was installed was an as-built drawing. This was intended to reference the form in which an on-site wastewater treatment system was actually constructed as opposed to planned. It was a detailed drawing showing exact dimensions, locations, and elevations of all components. However, after receiving comments from various engineers and contractors across Colorado regarding possible legal implications of the term as-built, it was determined that as-built drawing would be dropped and the term record drawing would be used in the 2018 update to Regulation 43, Colorado's On-Site Wastewater Treatment System Regulation, also known as the OWTS Regulation. As previously stated, the term record drawing is now referenced in Regulation 43. This typically refers to drawings that accurately represents conditions of a completed construction project. It does not mean that the drawing provided does not have to be complete and accurate. It simply provides fewer legal implications and seems to be more appropriate to the on-site industry. The Colorado Department of Public Health and Environment has Regulation 43, the state regulation of OWTS. Each county adopts Regulation 43 for their OWTS programs. A county may be more stringent than Regulation 43, which is why there is some variability in county regulations. The regulations for record drawings are contained within Regulation 43. So what does Regulation 43 say? Receipt of a record drawing, which includes a scale drawing showing all components of the OWTS, including their location from known and findable points, dimensions, depths, sizes, manufacturers' names, and model numbers as available, and other information relative to locating and maintaining the OWTS components. Note that while the regulation provides a reference to depths, actual elevations are preferred. Be aware that depths and elevations are not the same thing. Grading of the site may occur at a later date, which would make information regarding depths inaccurate. Elevation data will always be accurate. Again, this information here is a regulatory requirement. What is the purpose of a record drawing? A record drawing provides information to owners, regulators, OWTS practitioners, or anyone that may have an interest in locating a component for the system. Location of system components can be made easily and quickly with a clear, concise, and complete record drawing. This is critical when troubleshooting or maintaining a system. It provides a record of what was actually installed. Note that due to a variety of reasons, systems are rarely installed at the exact location and elevation proposed. When creating record drawings, consider the person that may be using it in the future, a future homeowner, pumper, a regulator, or an O&M provider. Remember that each of these persons of interest may have a significantly different level of understanding of how an OWTS is constructed and functions. It's also best to check local agency requirements. Certain counties may have additional requirements or require the drawing to be submitted on their form or in a specific format. Drawing similar to the one on this slide is what may be found in a search of old county files. This is obviously not acceptable. It is not an accurate drawing and does not provide enough detail for someone new to the site to easily locate each component. While distances are provided, what is the angle out from the building? Is 90 degrees assumed from the tank to the soil treatment area? This should all be provided on an accurate record drawing. Following a pipe is easy when the pipe is exposed. Make sure your drawings make it easy when it is buried. Record angles or provide swing tie information. We'll discuss each of these later in the presentation. Yes, we can do better. The slide provides an example of a record drawing whereby all components can be easily located. Note how distances are provided in a simple chart. Tank size, permit number, installer, owner are also provided on this sheet. If necessary, a separate sheet providing any other required data can also be attached, such as component depths, size, or other pertinent product information. Note how this drawing we are able to locate the distribution box, which is located near the header of the soil treatment area. The chart provides swing tie information from points 1 and 4. Point 1, the southwest corner of the garage, is 9.8 feet away from the distribution box. And point 4, the southeast corner of the shed, is 41.2 feet away from the distribution box. Using a tape measure, you could swing tie these 2 points and easily locate the distribution box. As previously noted, there is information required on the record drawing that is in addition to simply providing the location of each component. This information is critical for the operation and maintenance provider, as well as the installer who may be called out to troubleshoot a problem with the system. These items include, but are not limited to, septic tank size, dose chamber size, distribution media, distribution box or drop box, pump information, higher level treatment system, and any other information that may assist practitioners in completing a requested task. These items are not required by regulation, but are good to include for additional information to make the record drawing more complete and useful in the future, such as pipe length, slope of pipe, lot lines when components or setbacks are close, well location, and any measured setbacks to physical features. The items noted on this slide are suggested items that should be included on a record drawing, but are not specifically required through regulation. This includes the gallons per minute and total dynamic head for a pump, event counter and pump run meter readings, squirt height in a pressure distribution system, amps, and volts. Each item recorded provides an O&M provider or installer a basis of where the system started. The start point lets them know how the system is supposed to perform. This also assists in determining what might be wrong with the system. Bottom line, it saves time, and once repaired, it ensures that the system is functioning as intended. The next several slides will provide examples of the various ways of measurement in order to locate components. Using the swing tie method, which is basically triangulation for more than one point of reference, obtaining bearing and distance, both are needed, utilizing GPS devices or drone technology, which is somewhat new technology but can be very useful, and finally, using survey instruments. Again, we'll walk through each of these on the following slides. Distance off face of building method. This is not a suggested method because the measurements may be hard to duplicate. Sometimes you may be measuring a point along the face of a building, sometimes not. This point must be defined, such as a location of a sewer cleanout where it exits the home. What is the angle out from the building? Is 90 degrees assumed without any clarification from the drawing? Following a pipe is easy when it's exposed. Make sure your drawing makes it easy when it's buried. If you're following a pipe, you will likely need a bearing measurement, as this angle may not be 90 degrees from the face of the building. Swing tie method. Swing ties are easy to perform, accurate, easy to repeat. You need to use a minimum of 2 points of reference. If needed, use more than 2 points if it will assist in locating the component. More details on the next slide. What does permanent above grade structure mean? Just what it says. So above grade, locatable, permanent structure. It should also be locatable during snow conditions. You should measure to the nearest 1/10 of a foot. You could also use a high-end laser for distance. Again, use tape and rangefinder to get a comfort level for accuracy. Some examples would be a permanent building corner, a fire hydrant or a wellhead. You could try a fence or a tree, but those might not be best as they might be removed sometime in the future. Measure in straight lines. Trees can create a problem. Soil piles may make this difficult and cause inaccurate measurements. A third point tie-in may be necessary. When to conduct measurements. After installer has everything installed and still exposed. A minimum of 2 data points are required because one data point just locates a line or a circle, not an actual point. Note that this is for 2-dimensional drawings only. It does not include a vertical or z-axis. Again, it's not 3-dimensional. Identify in your drawing the locations that the swing tie measurements are originating. An example would be the corners of a house. Also identify the OWTS component that is being located. Make sure to properly label A and B or 1 and 2 corners on the drawing in order to properly duplicate the measurements. Again, take measurements and elevation for record drawing prior to backfill when possible. This is typically a two-person job in order to provide the best accuracy. This is an example of a record drawing using the swing time method. In this drawing, two corners of the house, A and B, were used to obtain swing time measurements to the OWTS components. The center of the risers and treatment unit were the components being identified. The corners of the STA were also located. The bearing and distance method. So you'll need a bearing tool, either a compass, Brunton, or a phone app, and then a distance tool, so a 300-foot tape measure or a laser distance measure device. A few items about this: compasses and apps can be off by a few degrees. Surveying is the only way to be completely accurate. These devices, mostly the Brunton or the compass, can be affected by close metal objects. Be cognizant if the bearing doesn't seem quite right. Verify phone app accuracy next to a device to get a comfort level. High-end lasers measure very accurately for distance. Again, use tape and rangefinder to get a comfort level for your accuracy. Bearing and distance protocol. Be sure to capture the bearing and distance on all system components and applicable structures. In this example, the easterly side of the house is noted as being 25 feet long and at a bearing of north 15 degrees east. The effluent line from the tank to the soil treatment area is 42 feet long at a bearing of north 51 degrees east. Be sure to include enough data to ensure that each component can be quickly and accurately located. This slide provides an example of a completed record drawing using bearing and distance method. The drawing on the left is a submitted drawing, and the drawing on the right is a blow-up of that portion of the drawing. Note the bearing and distances that are provided. Again, the pipe from the tank to the soil treatment area is 42 feet long at a bearing of north 51 degrees east. Note that the northeast corner of the house is labeled as point A. The northeast corner of the septic tank is labeled as point B, and the southeast corner of the soil treatment area is point C. Also note the table provided in the lower right-hand corner of the large drawing. This provides the bearing and distances to the southeast corner of the soil treatment area from points A and B. GPS can be used to identify component locations. It is important to understand the accuracy of the device that's being used. A typical smartphone is typically accurate to within a 16-foot radius. High-end users boost GPS accuracy with dual frequency receivers and/or augmentation systems that can result in real-time positioning within a few centimeters. If you're trying to locate a septic access lid in the snow, a 16-foot radius is not very helpful. Accuracy can be affected by signal blocking by buildings, bridges, and trees. A horizontal datum is used to measure a location across the Earth's surface in latitude and longitude or another coordinate system. A vertical datum is used to measure the elevation or depth relative to a standard origin, such as mean sea level, MSL. Since the rise of GPS, the ellipsoid and datum WGS84 it uses has taken the place of most others in many applications. The WGS84 is intended for global use, unlike most earlier datums. Here's an example of a record drawing completed using the GPS method. Each GPS coordinate should be in a table and correspond to the component on the drawing. You should be able to insert the coordinates as shown on the drawing to locate the components. The drone method is similar to the swing time method in that it uses distances between components. The drones have specific software that they use to extrapolate the data and acquire the distances. Certain drones over a certain weight may require licensing for use. Please check FAA requirements before using a drone to see what licensing is needed. There are also no fly areas for drones to be aware of. On the right is an example of a record drawing using the drone method. Drone Deploy is the name of the program used for the drawing. Other programs are also available. Surveying is the most accurate method. However, it's also the most expensive method to obtain data for a record drawing. The location of the components are surveyed and then transferred to a scaled drawing. You'll still need to add the additional information required per regulation to the final record drawing. Now that you have all the field data, it's time to create the record drawing. First, the drawing must be drawn to scale, which we'll discuss scales more in some upcoming slides. The drawing must be legible. Using a computer is optimal, but if you need to hand draw the record drawing, it must be legible. Use grid paper or the design plot plan when hand drawing. Some counties have downloadable record drawing sheets, such as Weld, Boulder, and Jefferson counties. Ensure all pertinent information is provided, such as tank information that shows the manufacturer, size of tank, material, is it concrete or poly, does it have an effluent screen or a pump, what are the models of those components, is the soil treatment area chambers or rock and pipe. A table used within the drawing is very helpful to reduce clutter and make the drawing more clear and easily readable. It is important to understand the difference between drafting and computer-aided drafting, or CAD. Drafting is using a set of standardized rules to represent ideas. CAD is an electronic program, is used to create a drawing. Using CAD is a great tool to create accurate and legible drawings. It's also much faster than hand drawing. It will take practice to understand the software, or it may be worth taking a class on it to understand it, but ultimately it does save time and is the preferred method. There are many electronic drawing software programs out there. The most popular ones used by engineers are AutoCAD and AutoCAD Lite. AutoCAD Lite is less expensive than AutoCAD and provides all the functions needed to create a good record drawing. There are also some free softwares out there as well. Do your research on them and see which one works best for you. Drafting rules exist to make the drawing clear and easy to understand. A leader is the arrow that has the text next to it and is pointing to the object it is describing. The example here has the leader is pointing to the oak tree. To avoid a confusing drawing, leaders should not cross each other or dimension lines. The example is showing a leader crossing a dimension line. This should be avoided. Dimension lines should also not cross each other. Depending on the scale of the drawing, the text and leader sizes will be dependent on the scale so that they are easy to read. The record drawing also requires a north arrow. It is best when the north arrow references the top of the page. The drawing is also required to be to scale. A graphic scale is highly recommended. The graphic scale tells what the scale of the drawing is and allows the viewer to verify the scale should the drawing be reduced or enlarged. Again, the graphic scale allows for verification and accuracy of the scale and thus the drawing. The more information provided, the better. Using a proper scale is very important in the record drawing to ensure legibility and clarity. The engineer scale is the industry standard and preferred method. Do not use an architect's scale. You cannot make up a scale. For instance, 1 inch equals 15 or 1 inch equals 70 feet is not a scale. Depending on the distances between components, most commonly used scales for record drawings are 1 inch equals 20 feet, 30 feet, or 50 feet. For larger parcels, 1 inch equals 100 or 200 may be used. Use what scale can be used to accurately identify the location of all components and still fit on the drawing. The goal of a record drawing is to be clear, easy to read and understand by all people who will use it in the future, concise, no extraneous lines or notes, and complete, so that all elements needed are provided and components can be easily located and identified. Remember, more information that you can provide, the better. Remember, providing a clear, concise, and complete record drawing makes the next person's job much easier. Thank you all for watching the presentation.